resume the recording. All right, let's get going. So how many people do we have? We have 13 people out of 26, so halfway. Um, so I'm a little bit, the coffee has not kicked in yet, so I'm going off of pure enthusiasm rather than actual cognitive ability. If you guys can't hear me very well, let me know, but it seems like you should be able to. What are we doing today? Well, first of all, let me just point out what we're going to be talking about first, and then we'll talk about it later. So last time when we were here, we were looking at how to evaluate visualizations. And you might say, why spend all this time on this? And it's because it's what I know about. Perhaps one of the big points of this. Evaluation is a huge aspect of the visualization community, or what we do for research. It is the only way you're going to get anything published, first of all, but it's also the only way you can back up what you're claiming. If you're claiming that you have the most badass visualization, or that you're solving the world's problems for X, Y, or Z, you better be able to back that up. And that's why we have all these evaluations. It's not just gut. It's not just, I feel like making a pie chart. It's not, I think it should work. If I build it, they will come, or anything like that. It's, if you make something, you better be able to back it up with some empirical evidence. And if you're measuring the wrong thing, you're wasting everyone's time. And so, again, I keep on going back to an old HCI class I used to teach, but it worked really well for this sort of thing. The very first paper, I'd have them read research papers, like actual published research papers, and evaluate them, just critique them, just like we're critiquing our visualizations. The very first one I gave them is something called Ninja Cursor. You can look it up if you want. It is a fascinating / hysterical read. Ninja Cursor, the idea behind Ninja Cursor is, if we're trying to reduce the speed in which it takes to click something, so you move your mouse over it and you click it, there's a known time, a known relationship between how far away it is, how big the target is, and how long it takes you to click something. So it's called, so a reciprocal tapping task, a Fitts law tapping task will tell you, Fitts law tells you that the distance needed to travel and the size of the target inversely related to each other. So the further you have to go and the smaller the target is, the slower it is for you to click this. Now, this might be a doy, but the fact of the matter is it gives a almost perfectly linear relationship. That's what's weird about it. You can map out, you can do a mathematical calculation, the linear relationship between the target size and the distance, which gives you the index of difficulty. It's logarithmically related to the time it takes you to click this or do this. It gives you this beautiful line. This is discovered in the 1950s, by the way, using like, I think it was a metallic, like a pen that would send an electrical charge. So you can actually time it based on an electrical charge, a circuit being completed. But it's been reproduced over and over and over again. It's our gold standard for what an experiment should look like. Well, they do the same thing with Ninja Cursor. They have not just one cursor, they have like a grid of 8 cursors or 4 cursors at a time. And say, look how fast it is for you to click this target. This thing got into the best conference in the world for HCI. And it's an absolute black eye to the field, because anyone with a half a brain in their head looks at it and goes like, you're measuring the time it takes to click this thing. There's 4 of them and you have 1 target. Of course it's going to be faster in that case. Put some distraction targets in there and see how it goes, right? It is bonkers that this thing got in at all, because it's measuring the wrong thing. If you don't measure the right thing, if you say, I'm going to reduce the amount of energy usage for people in the home, for the Green Monsters group, for example, if you are not measuring that, you are not measuring the right thing. If you're measuring how fast it is for them to evaluate how much energy usage they have, that's not the question you're asking. If you know the task, you know the question to ask, you know what you have to measure. You cannot measure random things. How many times they click this button, that doesn't tell you squat. You have to understand what their task is and if you're actually solving the problem. So this is why we're talking about this. I'm going to finish that off. And then later after this, then I'm going to talk about graphs a bit more, graphs and trees. and then we're going to see where things lead. So we're going to go over each of those parts, but I'm going to try and go quickly, relatively quickly. Quickly by my standards is, 40 minutes of me yammering on. Okay, so let's figure out what we were going to do. So first of all, I wanted to make two sets of announcements. We have Thursday, Tuesday. So next week we have a full week, and so next week we have a full week, and then we have one more class, I think, on the Tuesday. I think depends on how you want to do this. My original plan, and maybe I'm just crazy. My original plan was to have to not do live presentations. If you guys would prefer to do live presentations, I am more than, if everyone wants to do live presentations, I'm more than happy to have live presentations. It just means we need to shift things around a little bit. It means I need to not just take the last Tuesday of classes, but then I need to do, I think, the Thursday before that, when we're doing the usability testing for people to do their presentations. There's 7 groups, and at about 20 minutes a pop plus 10 minutes for questions at most, it'll add up, right? So do people want to do live presentations? Do you want to record a video and just present that and then have other people ask questions about your video? That would have to be all online, and it would be things like, it depends on how you would like things. It would kill off one of our classes, so that might be nice, but it also means the people that are presenting on the Thursday are presenting at the time of the usability test. So you'd be presenting, it'd be fine, but you'd be presenting your system before the usability testing. So you might have other things, feedback and changes to make, but that's fine. You'd have the usability test next Thursday, and then the following Tuesday would be the last day of class. The expectation is if you're presenting on the Thursday, your system would not be fully baked, it would not be fully complete, but it would be, close enough that you can demonstrate something. So I'm going to just float that over to you guys, to everyone here. Do you want a live lecture? Would you prefer live, or would you prefer recorded? Do you have a strong opinion on this? I don't know if I need to do a survey or if people just want to speak up on the chat. I don't know how you want to do this, because if you do the recorded lecture, I'm still expecting you to review everyone's videos and make some kind of comment or ask questions on the videos, and expect a certain amount of participation in terms of the questions being asked, and then other people, and then the groups respond to those questions. It gives it a more asynchronous feel, but it might take more time. It makes it a lot easier for feedback in terms of speed. It makes it worse in terms of polish, right? You can really think what your solution, what your feedback is, or what you want to say if it's asynchronous. But you're right, you can spend a lot of time writing responses or thinking about how you want to respond. Oh, that's right, time zones. Because some of you can't even, you won't be able to do a live presentation out loud if everyone in your family is asleep in bed near you. Um, that's right. Okay. I'm leaning right now. I'm leaning towards doing recorded versus live, simply because of the time sync as well. But I might then cancel the Tuesday class or something like that. Hey, I wake up at 6:30 every morning. Okay, that sounds fine. Oh, soon being quarantined. Okay. Hopefully just traveling, not actually getting COVID, but so let's do recorded, but just be, the standard is if you have a screw up in your video, um, if you have a screw up in a live demonstration, it's scarier, but the expectation is it could screw up. If you have a screw up in your video, it means you're just too lazy to re-record it. Just letting you know, right? You could have that video polished, right? It doesn't have to be perfect, but it should be on at a certain reasonable pace versus people. And then I am reading my notes, and right. You should be able to, it should be fairly loose and feel rehearsed, unlike that last sentence. Okay, that's number one. Number two, I'm unfortunately going to have to cancel office hours today. I'm more than happy to reschedule it to other times. I'm more than happy to meet people at other times. I just have something that came up at 10 o'clock today. So it's only today. But if you need help, I'm more than happy to help. I just can't do it at 10 o'clock today. So we're going to finish up talking about evaluations, then we're going to go to graphs. Oh, that's my upcoming lectures part. So the upcoming lectures, besides that, the recorded videos, uh, we got to figure out what we want to talk about. And you might think, well, don't you have it already planned? And I got things I can cover for the next 4 days. All the things I want to cover, uh, they'll actually be done other than how to give a talk. Most of the things we're going to cover are going to be done by I so they should be done by today. All the things I desperately, really, really wanted to make sure I covered should be done today. So we have a whole lot of different topics we can talk about, and I don't know what topics you guys are interested in. I stop using the word guys. It's not meant to be a gender pronoun. It depends on the circumstance, depends on the person, but how people think. Um, I want to see what your thoughts are because what my original plan was to look at scientific visualizations. That is things with a spatial quality, like a CT scan, like an airplane wing, airflow over an airplane wing. Um, we've already looked at maps, but we can also look at timescales. I have an entire lecture on multidimensional scaling. If you don't like math, though, I don't go heavy into the math, but it still might make up people's eyes cross. So I'm more than happy to do that one. There's a number of different topics we can talk about for so if there's a particular topic in visualization work that you went like, why aren't we talking about this? Let me know because we can talk about it. If you say, oh my gosh, I thought for sure we would talk about um, I'm trying to think of a really good example that you guys might everyone might pull up as an example. I thought for sure we'd talk about tree maps, spatial filling visualizations is called a tree map. Well, actually, we'll talk about those today, but I can talk about those. I thought we would talk about time series or time steps or collaborative visualizations, casual visualization. That's my doctoral degree, is visualizations used in casual context. I don't have a lecture on it, but I have a doctoral degree in the topic. I can make up something. I can make up slides fairly quickly. So if there's a particular topic you want, let me know. Otherwise, I'm going to stick to the more standard big ticket topics to talk about. Okay, so let me know if there's something you can put in the chat or you can tell me afterwards, whatever, if there's a particular topic you want to make sure we go over. Motivational factors surrounding visualization use in casual contexts. That's actually my doctoral degree. Okay, let's get going. Last time we were talking about evaluations, I gave a whole bunch of Sprague's general evaluation themes, right? Just because there are certain things that I see over and over again, like people saying, hey, did you like your visualization? That's one of their questions. And the person goes, yeah. And it means nothing, right? They're going to say yes. Of course, they're going to say yes. They're going to be good little participants. And if they say no, oh my gosh, you must have like kicked their puppy or something like that. That's no, you get a yes. Even if they don't want to say yes, they'll find some way of saying yes. So what I'm trying to say is there are certain things that when you're making an evaluation, conflating correlation and causation. Just because you have a correlation does not mean it causes that effect. It they're just a correlation. There are statistics involved. Oh, we can do a stats class if you want to do a stats class. I know you really, really love stats. Um, like people will give me a lot of times, they will try and do a lab experiment for something that should be qualitative in nature. So these are the kinds of things that to think about when you're designing your evaluation. Because ultimately, for your usability test, that is next week on Thursday, what are you evaluating? You should be getting them to do the task that you want them to do, like the task that you said was critically important for your system. Tell them exactly the task, tell them to do it. Don't tell them step one, click the file menu. Step two, do this. Say, I need you to find what the energy usage between Ontario compared to British Columbia is. I want you to find a fun activity to do in downtown Ottawa on a summer day. I want you to find the closest available skating rink to you in Ottawa. Whatever the case is, how disrupted is your commute? Whatever the task is that you said you was so critical for you to solve, that we all agreed on, that's the task they need to do, and that's what you are evaluating. You're measuring or trying to get a sense of how accurate or how well your system works. It's not a matter of did it explode into a into a fireball and a bunch of crying. No, of course it didn't, or at least it shouldn't. It shouldn't just randomly crash, but does it do the task? All right. This is the experience that you will always get when it comes to doing user evaluations. I just find it funny because every time it is one of the most frustrating things in the world. You will just be like, why? What? And half the time it's your fault, just letting you know. They will do something stupid and you will say that user is stupid. And then then if you really think about it, you'll go, I didn't give very good instructions. Or there's something else at stake. So I had a participant asked, we did what's called a stereo fly test. You put on 3D goggles and you look at this picture and it's supposed to look like a fly that's popping out of the screen. I'm going to move that on. It's supposed to be, looks like a fly that's popping out of the screen. And you say, pinch the fly's wings. I had one participant uh, who was a professor in a university right now, in a very, very good university right now. But I asked her, can you pinch the fly's wings? She goes, what do you mean? Pinch the fly's wings, I said. She went, just poked it and knocked it over. And you're like, what? She didn't have stereo vision. She didn't know she didn't have stereo vision. Like two different eyes seeing depth by the difference between your eyes. No clue. That's why we have these tests. That's why you have to change the wording to make sure that you're not making the person feel crappy, right? Because that is a perfectly, that's an actual thing. People will, you think they might be doing something stupid, but maybe you're not. Maybe you're doing something stupid. Okay. We already did that last time around. So let's talk about what kind of, and by the way, I was very impressed with what you came up with last time around. We were looking at what kind of evaluation you would do for your system if you had the time and infinite resources, that sort of thing. So what kind of practices do you do? That's one of our big questions. This is something we're not going to be doing here, but this is essentially what you would have done if we had the time for task one. What we have is, what is their work? What are they doing? What software is in use? How does it inform design? What kind of things do we worry about in terms of adoption of the system? This is one of those fly in the wall kind of evaluations. And the kind of evaluation question you'd ask are like, when is it used? What's the context of use? How do I support their daily activities? What kind of type of analysis are they doing? What are the kinds of tests? I'm just going to blow through all these. What kind of things are they doing? I want to know what they're actually doing now, what their actual task is. I want to understand the domain before I build a system. I talked about this last time with tabletop displays. Tabletop display is just a big old screen that you can put a visualize. You can put it's like a user interface, but it's on the top of a table. Except they didn't know what to make for a tabletop display. It was just Windows on its side back in the day. And if you study how people do puzzles together, how people collaboratively work around a table, the behavioral pattern is very different than on a wall. It's extremely different compared to two people using a mouse and a keyboard. And that might seem obvious, but exactly how they do it requires a lot of study before you build a system and find out it's wrong. I was doing casual visualizations and I did an artifact study, which is, well, actually, we'll get to it. What kind of methods do we have? We can do field observations, like go to a place of work and look at people. Real world, real free, or release a tool and see what they use. Right? What kind of requirements are there? Like, what can you do? Or you can interview people. So you go to an architectural firm and you interview them and see what they're doing right or wrong, or why they do the things that they do. People will do this wrong. You need multiple sources of data. So the interview works fine. The field observation works fine, but there's no perfect study. And so if you observe people in the field, it might just be an off day. If you interview people, they might think one thing, they actually are doing something else. They may also not want to tell you the real truth, why they do this, that they steal, like, well, if you're doing field observation, someone's watching you, you're not stealing pens from the office. If you're interviewing them, they'll tell you about all the hard work that they do, just in case it goes back to their boss. You may not get reality, and it's a very, very difficult thing to actually design properly. You also got to pick the right person for their interviews, by the way. If you just get some random person that doesn't know, that doesn't have the domain knowledge, it's not going to work very well. You can also put them in a laboratory context. You can bring them into lab, ask them to do something, and see how they go about doing it. One of the big things in the field for HCI is collaborative. So it's participatory design. Getting a real user to be part of the design process. So when you're building something and designing things, they are helping make the decisions for what features need to be in there, what features don't need to be in there. You're designing for that one individual person a lot of the time, which we're not trying to do. That's what I was getting a little nervous about for some of your projects. You were saying, what do you want to see in my system? And I'm like, I don't know. It's not about me. That's me choosing what the system is for me and my use case. See if you can come up with the more general solution if possible. I am one data point. It's better than 0 data points, but I'm not the be all and end all when it comes to how you find a skating rink in the city of Ottawa. This is one of the things I did for my PhD, an artifact study. So one of the weird approaches you could take is you give either artifact study got co-opted by the computer science community. Originally, it's like an art piece where you give them some kind of evocative thing, like a little pillow that you're supposed to fill in their dreams on, or you give them seeds to plant and you're building up plants, but it's also getting them to think about how their family tree works, or there's some crazy artifact studies. The way a lot of computer scientists do artifact study is you give them something like a journal essentially. You give them something to think about on a regular basis, something that's evocative enough or interesting enough that they want to do it all the time, or they want to uh, they're reminded what they need to do. Maybe you give them a whole bunch of thank you cards. So when we were doing the Dear Data visualization, or just Dear Data visualization, make a visualization or a visual representation of data for things you see in your daily life. That makes you pay attention to things you're seeing in your daily life. You make the visualization, and then you interview the person at the end to get more information. But because it is different than what they normally do in their daily life, it means that they're attenuating to those details a bit more than just directly asking them questions. Say, why did you do this? So we had them take photos of visualizations they hit in their day-to-day life and see what they said, and then interview from there. You can also do lab observations, bring them into a lab, have them do a task, see how they do. How do they interact with things? But they're experts, so figuring out what you have a more controlled situation, but it's not environmentally realistic. One of the examples of this is architects. My supervisor went into an architectural firm. They have all these different blueprints. They have screens on all the walls around them. There's a lot of money at stake here. How do people collaboratively decide and think about and look at designs for a building? And now, if you're going to make a system to help architects collaborate and decide on what the building should look like, you can't just randomly guess. You have to know how they're currently working. You need to know that they're sitting around a table, and so it's this flattened surface where everyone's collaborating, and who takes turns, how you have to understand that part. You also understand how data is being passed around, how one person passes off a blueprint to another person in order to build the system correctly. All right, just a little side effect. You can look at this slide again later. This is just a little mini break to fix your brain. Yes, this is the number of Imperial troops, and the number on the center line is the number of Jedi that are around at any given time, and major events like this is Rogue One, this is Battle of Yavin, which is A New Hope, the Death Star blowing up, that sort of thing. Battle of Hoth is right here. Oh, this is their sort of that gets destroyed here. Anyways, when they go to the asteroid field to go after the Millennium Falcon. Anyways, I just find it funny. All right. How do you evaluate the reasoning? What we want to be able to do is just figure out what kind of insights people have. Can you say it is, they get better insights? So if you're talking about does support data exploration, data discovery, hypothesis generation, decision making, one of the big things here is if you have a biologist that's looking at a visualization, the speed on task is not what they're worried about. If you're looking at investors, the speed on task is not what you're worried about. It's not something that you can easily quantify with a number. It's more what insights do they get. So how do you reason about your data? What kind of knowledge or discovery do you get? It's very hard to measure. We often have case studies. We can see motivation of see experts looking at their own data. Oftentimes there has to be their own data. Oftentimes you have to do longitudinal. So as in you spend 6 months, a year, figuring out how they're doing with your system over a long period of time. You can't just bring them into a lab and have them run things. It doesn't work. What kind of insights they gain, whether so like unguided, it's a diary, you maybe have a diary, and you also have debriefing meetings. You can have multidimensional, in-depth, long-term case studies, just long-term seeing people use your system for years and repeatedly reporting how things are going. Now, technically, so improve system during when it's being used, what kind of user performance we have. We can do lab studies. We'd have to code results, what kind of insights they get. It has to be maybe think aloud, but it doesn't lend itself to like speed studies or really controlled experiments. Although you can do a controlled experiment, but then you have to really pick your factor and it's really hard to do. So if you want to see an example of this, I have brought up your different studies. So one of the big things would be the IT crowd might be okay for this sort of thing. The big one would be the data dudes group for this, which is why it's so difficult to actually evaluate that particular system. You're talking about people investing in Ottawa, using your system, trying to make insights on where to spend their money. It's not about time on task. It's not about speed. It's about coming up and figuring out the little quirky thing that no one else has figured out that gives you a competitive advantage when you're investing. And therefore, it would be develop a system, have them use it for a long period of time, and figure out if the conclusions they made them make more money, for example. But it's not going to give you a nice, statistically significant result. It's going to be a lot fuzzier than that. We can figure out communication between within the visualization, how I go from the designer to the user. And this could be things like how effective is my message delivered, and it could be quantitative, my learning rate, how fast I learn certain things I want to learn, how accurate my understanding is. Might be what interaction patterns I have. That might be something I study. How long I use it for, what things I clicked on. And our methods often are controlled studies or field observations, interviews. I could even release a system. For me, the two examples here would be, capital rate it's going to be hard because you don't have the right data, but the, the IT crowd, but the red light group would be an example of this. You have a particular hypothesis that red light cameras are not that effective. Right? Do your users come to the same conclusion, or are they coming to a different conclusion? There's another one in here. Local activities group, testing. Oh, wasn't gonna. Those are great groups, but they're not necessarily the green monsters. There you go. The green monsters group. You're trying to reduce energy usage for people in various households, and the claim is that by seeing this data, they're going to change use patterns. You got to back it up, right? How do you know that your system works effectively? That's the kind of study. If you're doing a real study, this is what you would be looking at. Do people actually make any meaning from this New York Times visualization, for example? The New York Times passed to the House of Representatives. How do people come up to the House of Representatives for the Democrats and Republicans? And did you see a particular pattern? Do you see the pattern that the original designer wanted to see? We also have collaborative data analytics, or data analysis. This is something none of our groups are doing, but still interesting. How do you support a group of people working together, like architects, right? You need to have a holistic understanding. We have particular design implications based off of how they work together. And efficiency is not necessarily the most important thing. You got to understand how people are working together. It's actually really hard to do. This is one of the nastiest evaluation types. It's a thing that everyone warns their PhD students not to look at because it's on visual analysis, like a visualization analysis. Over on top of that, but you also see multiple participants at the same time. What kind of insights do you get? Multiple people working together. You're not going to get a nice clean p-value or a nice clean statistical value. What kind of change? What kind of communication do you have? How do people take turns, for example? What tools do you use? How do they hand off ownership of something? What are my user requirements? It's very difficult to say you have to collaborate well in this particular case. Sorry. This is actually a very challenging thing. How do you get people to work together to analyze data together? And luckily none of your groups are looking at that thing, but it's really hard. Sometimes I have groups that want to look at this. So oftentimes you need to put it into context. You have heuristic evaluations, what kind of mechanisms you need. One of the things is you can release it in the wild and log the data. See who picked up the pen or who was interacting with your system at a particular time. Can do questionnaires and interviews, for example, as well. And then it's very hard to evaluate, but we try. Or you can bring them into a lab study and get them to see how they work together, how they don't work together, when conflicts arise, and what kind of insights come up. So one of the problems is, do the users have to know each other before you start measuring things? They will not have those social connections to figure out how turn taking works. They'll be working on this social aspect and your system at the same time if they don't know each other in advance. That might be interesting, but this is a compound to what you're looking at. So the classic example would be something like this. If I'm collaborating around a tabletop, and two people are working on the system at the same time, how do they work together? What kind of conclusions do they make? It's not just a matter of, does the system support things? It's a matter of, when two people are looking at these data, can they come to better conclusions? Two heads better than one with this visualization. Okay. We have evaluating user performance. This is just our default. Everybody wants to do this approach when they start a visualization. Maybe not you guys, but this is the classic, right? I have a system. I want to show it's 50% more effective. So I have specific measures like time, accuracy, and error, work quality, and memorability maybe of the data. What do I remember about the data itself? And I want some descriptive statistics. I'll get some p-values. I will get that my system is 50% faster than this system. This is normally the red herring, if you will, of the visualization community. I'll make this system. I'll be trying to measure something very precise in a lab study oftentimes. So how much, what can a human perceive? What do they realize? How many numbers can they keep in their head at once? Is my system faster than the other's technique? It's what everyone does. I do it. That's what I want to put in every single one of my system every time I evaluate. And most of the time, it's controlled experiment. I bring somebody in, I show one system, I show another system, measure their time, done. Except oftentimes you will find a fake. You're asking the wrong question. Oftentimes you will say, my system is 50% faster than the other system. So and sometimes that's useful. So sometimes it's not. So The green monster system, if you're saying it's 20% faster at looking at your system compared to looking at a table full of data, okay, you're missing the point. That's not the key metric. You're trying to see if you can change behavior. With an environmental visualization, you want to change behavior or have insights about their environmental impact. You shouldn't really care about how long it takes. That is a sort of a secondary feature. It's extremely important for the working women on the go group, though. They're going out the door trying to get to work. If you want that, you need to be able to quickly and easily spot bottlenecks. You have to quickly and easily figure out how you might need to reroute your daily commute. That works really well for evaluating user performance. That's what you want. How fast can you get the insight about a traffic jam? So you set up a traffic jam on the map. You say, what's the fastest path from here to here? You measure it with a conventional system or just with some numbers. You measure it against, so you have some kind of control condition, that default standard for how you would look at this data now, today, maybe a Google map, for example. And then you use your system and you compare which one's faster for reading off the data, or what path you would take from point A to point B. Now, the quality of the path might be a different metric. That would also be something to look into, but it's not. The time on task for working women on the go makes sense. It makes no sense for the data dudes. Who cares how fast it is? You want insights about the data, how you're investing. It does matter for the local, it matters for both the local Ottawa things. So the capital raters, speed on task, right? You do sort of want the quality or the how satisfied you are with a choice of restaurant or activity you're going to do, but you also want to be a certain speed doing that. You want to be able to find a skating rink quickly. You want to be able to find a COVID testing location quickly and of a certain quality. All of those work well for this. But if it's something that is requiring a long time with the system, that's not what we're measuring. Okay. With a controlled experiment, though, it has to be controlled. So you have very few variables. You control every last thing of it. You give them a simple task, and you see if it improves with your system compared to control. The control being the standard way of doing it. So if I'm comparing COVID testing cases, find a COVID testing location near you using the current website that the City of Ottawa has. Find a COVID testing location near you using your system, which is faster. Or give them the address where they're finding the location from, not just, so they don't memorize it. Pretend you're in Canada. Find a COVID testing location near you. Pretend you're in Barhaven. Find a COVID testing location using the conventional way. And one of the problems is, unless you're doing a within subjects design, as in the person does both conditions, if you have one person doing the experimental condition, one person doing the control condition, individual differences will kill most of your statistical chances, right? The individual differences between people. Some people are just better at doing Google searches, right? Or reading. Some people read faster than others. Individual differences can really throw off your data. You can also do field logs. This would be an example. This is from Heidi Lam way back in the day. I was actually part of this experiment. That's why I remember it. Right? She's just trying to test, can you perceive or can you read off the data in this visualization? The Graph Line Explorer, really dense visualization with a lot of data at once. Can you make sense of this? Or is it faster for reading the data off of this compared to some conventional method? And then we have the user experience. This is this general limits in functionality, limitations, directions for improvement, user responses, a lot of interviews. Is it effective? Is it efficient? How correct is my data? But they're often subjective responses. How much do you trust the system? You might see a statistical test on trust, but it's a person reporting it. That's going to be biased as anything. Do they like or dislike it? Do you like this system or not? And the answer is yes, I like your system compared to the conventional one. There are objective ways. You can do body trackers. You can do eye tracking. So body sensors, galvanic skin response. If you get really frustrated, you can actually detect that. Things like that would be fine. And you can also do evaluation questionnaires. How learnable is your system? It's the general sense for the system. Now, that's effectively what we're doing. Our usability test is a very rudimentary form of user experience testing. We can do informal evaluations. That's what we're going to be doing. Oftentimes you'll get a domain expert and talk to them. Here's our usability test. How do people perform a series of tasks? Where do they get stuck? How many swear words do they give you? And you take notes of their behavior. That's what we're doing. So for your usability task, you're giving them the task, and normally you'd actually be watching them taking notes. So when they curse and swear at your system, you note how many times when they do that, right? That's the bottleneck. That's where the pain point is, where they get all confused and they do this kind of thing. What? Yeah, take a note of that. You don't have that if you're doing it remotely, but we're trying to simulate that. The big thing is you got to carefully prepare your task, your interview script, and your questionnaires. You have to prepare everything in advance, and then you need to improvise afterwards. It's challenging. Field observation would just be go in the field, see, go to an airport, watch people what they do. It's fascinating. That would be part of the user experience. Seeing how many people scream and shout at the airport will tell you what's wrong with the airport or what's wrong with their system. Seeing someone play a video game, and when they throw their controller across the room due to some glitch in the game, that'll tell you what they're doing. Or when they use their phone, when you're using your phone and people, have to try and unlock their screen like 3 times. Part of usability. Also seeing how angry they look when they're trying to unlock their screen 3 times. And you can do it in with Likert scale. You can do it open-ended questions. You can do it in more lab study, but meh. And then finally, this is the one we're not even going to cover. How efficient computationally is one system compared to another? What shows best patterns, what looks the best, what gives you what's more truthful, what's more accurate on the screen, which is less cluttered. How much memory is it going to use from the system standpoint? How fast is it? How does it scale to our data sets? Let me give you an example of that one. Algorithm performance. Okay, there we go. That would be one of those examples. 2 algorithms, I run them against each other, one after the other. I give them the same data set, time both of them, whichever one's faster, that's the better algorithm in some cases. Maybe give them a whole bunch of different data sets and run those simulations. We aren't doing that here. You're probably never going to do that again, but that is the gold standard for most systems evaluations. Clock time works. So hopefully that. So this is what we've been looking at. To reiterate what we've been talking about so far. For project 1, we figured out the task. For project 2, we figured out we figured out the user, figured out the task, we figured out what kind of interaction visual idiom we have. That's project 4 and 5. Our designs. We did a whole bunch of sprints to develop this thing. We're not testing that part. And then project 9, or is it 8? Anyways, my number might be off, but the usability test at the very end to make sure that we hit our mark. That you said your system helps you find skating rinks in the Ottawa area. Does it? That's what we're testing. How fast can they test it? Do they understand what your icons mean? That was a thing I've been picking on there, that group. And by the way, before I finish up here, from the systems I've seen so far, and I have to look at the rest of the systems, but from the systems I've seen so far, there's some phenomenal work here. I don't, how do I want to phrase this? I feel bad whenever I push students a lot, and then I see what you do, and then I go, holy cow. And it's amazing work that you guys are producing so far. So keep it up. It's very impressive. Okay, so when we are finally evaluating our system, can you do what you expect to do with it? Can I find a place to get a COVID test? Do people understand what the icons mean? That's a problem we were hitting with a COVID group is they have two icons, they're distinctly different, but I don't know which one means what. Is the green cross or the green background with a white cross in front of it, is that for COVID testing? Is it for vaccinations? What is it for? That sort of thing. That's what the usability test is for. We're not doing the rest of this stuff, but we are following a large chunk of the development process. And my take home for the evaluations are, you're never, what I want, I'm not going to expect you to remember all of those things that we just blew by, those 7 different approaches. What I want you to take away from it is you need the right tool for the job. We have a whole bunch of different techniques. And what people will give me oftentimes is they will just say time on task, how long it takes you to find a particular data point. But is that the task you're asking people to, is that really the gold star measurement you need? If you're talking about investing money, it's not the time it takes you to find a good investment. It's not the time it takes you to use the system. It's the quality of the investment opportunity that you find, for example. And so you have to think long and hard when you're talking about evaluating your system. You have to think long and hard about exactly what approach you're taking. It's not one size fits all. It's you custom make your evaluation based off of what you need to back up, what you need to prove in the end. Okay, so with that, I'm going to switch gears. We're going to go back to trees and graphs, but let me pull that up now. So that was just this deep dive, really quick. When you do a usability, when you go to an HCI class, I don't think you've had a full-blown HCI class yet. Can someone correct me or confirm or deny this, that you haven't had a proper UX kind of class, HCI class? All right. Nope. All right. You could spend, well, literally, you can spend years and years and years just studying how to do user evaluations. Even by the end of your degree, you'll have a couple exposures to it, but you won't, I'm assuming you're not going to necessarily be experts in it. But people underestimate how difficult it is and what you're trying to do. I've had enough graphics people, bash HCI. They go, oh, all you're doing is trying to do is figure out what color scheme do you make something. Like that was literally the comment I got from one of my colleagues. Uh, it's kind of disconcerting and kind of depressing. So let's do this, but it's a little disconcerting and depressing, but people think it's just, what's your gut tell you? No, it's not gut at all. You make a design, you validate. This is not art. This is design. It has an artistic component to it, but it sure as heck isn't what you feel like. It is, you back up what you claim. You claim it's going to help you reduce environmental impact, back it up. If you can't back it up, this is the real world. You can't necessarily back it up for this class. But if you claim you're reducing environmental impact, you better have some data to back it up, right? That's what we're aiming for. That's what I want you to walk away with afterwards. You can see all these visualizations till you're blue in the face, but it's not how you feel. It's, does it do what you claim it does? Do you get insights? The visualization community would not have taken off at all if it wasn't for the fact that you can back it up. When you release a system and you give it to people, do they make meaningful insights based on the data? If you give them and that's why it was so big for genetics and so big for stock market analysis. Because when you released it to them, people made money, they made insights about the genetic sequences, they got more publications or they got more money. And in both cases, the proof was in the pudding, so as this expression goes. At the end of the day, you saw the impact and they were able to measure how important this thing was. And therefore, that's why you do a system a particular way. is not just how I felt like I wanted to design it. You backed it up with something. By the way, in case you're wondering, they're doing that with every one of your phones. They're doing that with every one of your systems. They're doing it with every game console. All of that stuff is measured and properly evaluated. That's why things keep on getting better in terms of like user experience. It's not guesswork. It's not somebody just having this, oh, I know how to make a user experience. No, they're backing it up. Every single thing that they do, if they have a design, they bring data to it. It's and the times when Apple sometimes lies and says they don't do user evaluations, that is a load of horse crap. I will say Google, if you ever do if you're using Google Maps or pretty much any of their apps, or especially their websites are really good examples of this. You'll sometimes see the interface change. It will look different one week compared to the next, and then it'll go back because you're part of an ABA experiment. They will randomly throw out a refinement or a change in their interface to a subset of the population, see how they use that interface just temporarily, and then revert it back. And they can measure the time it takes you to do a particular task, how frustrated you were, abandonment rates. They can test a bunch of things with log data to figure out if their new interface is actually beneficial or it's actually an improvement. They don't guess, they validate. Okay, trees and graphs, completely different topic. So last time we were looking at this, we talked about what a graph was. It's not a graphic. It is it's like things, what is connected to what. We're going to look at trees as well, a special kind of graph. But turns out a lot of studies on how to do it. This is actually where the visualization comes in. This is actually where the usability testing comes in as well. That you can actually produce graphs, give it to people, see what insights they have, or what they like more than others, or how accurate they are for reading off information from the graph. And so we have a lot of heuristics based off of empirical evidence that has been collected over the years. The nice thing is you can make artificial graphs, measure it on people, so you don't actually have to have real data. See how this is one of those utilitarian kind of measurements. Give them a couple graphs, measure how accurate their readings off of this thing is statistically significant compared to the other one. There's so many things with graphs that it becomes this field where you could just keep on making research projects on this thing because it's so the internet was, I mentioned him before, Dan Archambault looks at extremely big graphs and how you scale to like, I want to see all the nodes on the internet, go, or all the major nodes on the internet, go. That's really difficult. And therefore you need ways of scaling it. And now you need to measure whether you've actually ruined someone's ability to see patterns with that. So semantic rules of IP, place specified vertices in a straight line if you can, right? Don't wiggle them, put them in a straight line if you can. You want a curve rather than a wiggle. You want to draw vertices with specified sizes rather than just random. If you want to spread things out, specified vertices should be placed nearby for related vertices. If I have a structure like this, I want to. People tend to like a spoke orientation. So you have some central point and everything works around it, forms a circle, right? We like symmetry over asymmetry. And when you may have a graph that you like more, it's easier on the eyes, but it's also easier to read off of. The big one is avoiding overlapping edges and overlapping vertices. That was one of the big things. It's better to spread it out and have these curvy lines than overlapping things. And it's even better yet to keep straight lines and no overlaps if you can. And so you can actually measure the quality of a graph layout based off of these metrics. But minimize the average length of edges, for example. The edge, or they should match the weight of the edge. If you ever want to figure out if your graph looks good, you can consult a table. You're not going to memorize this stuff, right? But it's well established. And so what we were talking about last time is we can make a graph. It has a vertex, a data item, if you will. What it connects to, they might be directed, There might be weights on these things. There might be weights on the individual vertices. We could categorize the different edges. We can categorize the vertices themselves, like for example, using color. They don't have to be straight lines technically, but people like straight lines with this. There is this is for such a simple concept. There is a ton of stuff you can do with this, including this. Technically, we talked about this when we came up with maps, and I'm going to just pull it up anyways. What the heck? The history of the London Tube. Okay, we're going to, we value your privacy, but we're going to put cookies on your computer. Okay. Here is the original underground tube for London before it got complicated, by the way. So this is, the hell kind of crazy ad is this? And why are they showing it on my computer? Okay, so here's the original underground tube. Look, all the lines and weird stuff that you have here, right? All these curved lines, because it's mapping it to the actual landscape. It's a graph, though. That's one of the big things for Metro maps. That's the term for it. Metro map, the big takeaway, the big sudden realization comes from someone that was working on the tube and who actually came up with this particular mapping approach. So this is when you get a bit further on and more development happens. Now imagine trying to find out where you're going with this thing. It's crazy pants, right? And even more curved stuff, random stuff. This comes from someone that was actually working on the tube, and straightening the lines helps people read the tube map better. It is actually a graph. This is connected to this, which is connected to this, which is connected to this. It is not connected to anything else. It is a node link diagram. It has a spatial component, but it's a node link diagram. So you're trying to map it to geography as best you can. But the better thing to do is try and keep straight lines, trying to avoid overlaps, even if they overlap multiple times. And so you get this nice format where you're laying out your, and it was done manually, at least at the time. I think it's still done manually. You're trying to figure out what is their special, when two routes go to the same place, right? Where there is a transfer point, there's a special, you'd have a special symbol. You have different symbols for the lines themselves, for the edges themselves, and for the vertices themselves. I think this is the most modern version of it, but you can clearly identify the different major routes, the trains going into it versus the actual tube system itself, where the transfer points are. Notice how highlighted they are. You can see each individual thing, but the key is I want to get the overall view, the structure of the map. So I'm emphasizing certain nodes because they have a high weight, because they're transfer points. I don't really care about this stuff. If I'm figuring out my commuter rail, I'll look at that carefully. But the vast majority of people are, if you're a tourist going into London, you care about where the transfer points are. Even if you're commuting in, you care about where the transfer point is. And you need to be able to read it off quickly. It's no link diagram stuff. That's all it is. So if we have anything else, oh, that changed. That changed after back. Okay. Oh, there's all sorts of ugly crap in here. Okay, and then we have different zones. So notice we also have gray zones, and we can do encapsulation with our vertices in an node diagram. The tube is really, really complicated. And to be able to pack in this much information at once and have it readable by the average person is actually a big challenge. The nodes are more noticeable. The major nodes, the major thoroughfares, the major places where people come in, you have some references and some landmarks like rivers. You have the pricing zones drawn, but minimized with a gray in the background, and using encapsulation to show when something is in a particular zone or how many zones you're crossing. You have the commuter rail, which is not as obvious as the major lines that you're riding on, but at the same time, so you have weight on the edges themselves. You have color actually identifying the different routes that you're taking. You're minimizing overlaps, and you're trying to get out all of the fiddly diddly stuff when it comes to the line itself. You care about one vertex to the next. I can't get off halfway or at least you really shouldn't, get off halfway between two train stations. Therefore, you just want to have a straight line between two train stations. It's a network. It's an edge between two networks. All right. And then people take it and they just beat it to death. So this is, I don't even know what the hell, epidemic rapid transit map. So this is how epidemics are going around the world at various times and from the UAE and various countries. It's a network diagram, but they're trying to make it look like a train station. I hate this crap. Trying to reappropriate something. A metro map is designed for a subway system. That's its point. If you try and force it into some other context, it makes no sense in my books. Like periodic table of visualizations, get that crap. Sorry, I'm being opinionated here, but get that out of here. No, periodic table of elements is designed. It's a beautifully designed system, right? But it's designed for the periodic table of elements. You shoehorn anything else in there, you're just wasting time. All right. Here's some other weird things about this. I'm not going to go over all of them. Hopefully you recognize what the silhouette of this is. This is the United States. We have a whole bunch of cities in the United States. This particular system allows you to brush a particular area of these cities in the US and shows I've brushed this area, I've brushed this area, I've brushed this 4 different areas. And now I show the edges only then, details on demand. I show what edges are connected to what other cities in the US. So by selecting particular areas, I can see how many connections I have between here and here, how many are connections between here and here. If I showed everything all at once, I wouldn't be seeing anything at all. I have a graph that I'm selectively showing the edges for and trying to mute all the other nodes, but it's still a graph. And I'm still trying to reduce the number of crossings by keeping them in parallel and keeping them approximately the same, but it's an arc as well. I have, here's another node link diagram. I have things in Washington connected to other things in Washington with 717 connections. I don't even know what this graph is anymore, but here's a visualization per individual city. Notice they're located approximately geographically correct for the United States. And we see connections between Montana and Washington. I think it's actually mapping this thing here. So Washington state to Montana right here, this thing here, the number of connections within the Montana region, this area here that I have, how many connections, internal connections there are, how many connections to other, trains going from Montana to Arizona, and how many are going from Arizona to Montana. The nodes of the vertices themselves do not actually have to just be a vertex. They don't have to just be a dot. They could be a pie chart. I know, maybe not pie chart. They could be a bar chart. They could be some kind of glyph of various formats. There's a slew of different customizability that you have with a graph, especially with a node link diagram. So this is just an example of that. Adjacency matrices are the less intuitive, but far more computer sciencey branch of graphs. So here is a node link diagram. People know that A is connected to B, which A is connected to C, B is connected to C, B is connected to D, C is connected to E. Okay, you can read all that. Most people sort of naturally understand this. This is the exact same thing. A is connected to B and C. B is going to be connected to A, C, and D. A, C, and D. They're all connected to B. C is connected to A, B, and E. D is connected to B and E. E is connected to C and D. You'll also notice that we get this symmetry. If it's an undirected graph, A is connected to B and B is connected to A. We could do a directed graph, which we would only have one of those two. But if it's a undirected graph, as in there's no directionality of the arrow here, it'll get AB and BA. But that's all an adjacency matrix is. I can color in if there's an edge, put a 1, color it in, whatever the case is, or leave it blank. That leaves us a whole lot of things that we couldn't do before. It's the same data, different visual representation. It's one of our main ways. So it's great for dense graphs. Node link diagrams, like the node link diagram, is really hard with a dense graph. You get a hairball problem. Everything's connected, everything else, and you just can't see anything. It scales because it forms a nice little grid pattern. You know the exact size. You can predict how big that thing is. You don't have all this curvy lines and stuff. I can spot clusters if I lay it out properly. That's a big if. But the row order affects what you see. So if I have a cluster, but they're distributed, I don't see the cluster. I do with an old diagram, but if I don't lay it out properly, it'll affect how I view things. It's very abstract. People have trouble reading it off. I still have trouble reading it off, and I've been doing it for years. And hacks are really hard to follow. So A goes to B, and then B goes to C, and then here's C goes back to B, it goes to D, and D goes to B, C, I've already got visited that, E, and then that's it. If I want to find the path from A to E, I have to go A, B, B, C, C, D, D, E. Right. It's hard to read. A lot harder than just use your finger. And you can combine them, by the way, in case you're wondering. So this is my node link diagram of the exact same information. Here it is as an adjacency matrix. Notice when I have a click, or fleet, depending on how you view it, when I have everything's connected to everything else, I get this sort of thing. It's just this big hairball. It's very easy to see that everything's connected to everything else, provided I lay it out correctly. But so if these nodes were distributed throughout this entire thing, I'd be in trouble. But as long as they're clustered together like this, I see everything. I see that this thing is connected to a whole lot. So whatever this node here is, it's connected to a whole lot of different things. Same thing here, same thing here. But this sort of gives you a better feel for it in some cases. And I could show both representations at once, or maybe I can show a cluster and then put a matrix in there instead of the node link diagram. They're just different representations of the exact same data. And some are better, some work better in some cases than others. So we can get, here's Les Miserables, the co-occurrence of Les Miserables for all the various characters, for example. Here is high glass. This is a bunch of genetic data and what correlations you have with the various genetic sequences. And you can see particular patterns in here. You can see what correlates with what for various things. If you had this as a node link diagram, your eyes would bleed. It would just be impossible to try and read that thing off. But notice I can do, instead of saying yes, there's a connection or not, I can do weight on these colors. If there's a whole lot of weight between 2 points, if it's really fast, a really fast network connection between A and B, I could color it darker than there's a very, very slow internet connection between A and B, color it lighter. And now I get the fastest path approximations. I can get sort of global approximations here. Really bad for paths, but really great for overall view. Here would be, and here is the node tricks thing. This is that combination of node link diagram and adjacency matrix and node link diagram. I have each one of these things being a cluster of people together, a node link diagram, but I'm converting it to an adjacency matrix. But then I use a node link diagram representation to connect these clusters together. So Xerox PARC, a very famous lab in Silicon Valley. Xerox PARC, all these people that worked in Xerox PARC and who they're related to. Berkeley has a lot of connections between Xerox PARC and itself, but not that many. Just it seems like one connection. But everyone at Berkeley's really highly correlated with one another. Ben Benderson, Catherine Plaisant, and Ben Schneiderman work together a lot. They're all in Maryland, University of Maryland, and these are their public co-publications amongst their various students who they're working with. But notice, with their students, they're more tightly connected than with each other, but there is a connection. This is Carnegie Mellon. And who are they connected to? They're actually not connected to Xerox PARC, surprisingly, but they're highly connected. They're connected to these guys. They're not connected to Berkeley. You can figure out who worked at Xerox PARC. I have a best of both worlds. The sparsely connected stuff I use in a node-link diagram, and when it's really tightly connected, I switch over to an adjacency matrix. Or I can do things like this. Here's a node-link diagram. It converts over to an adjacency matrix for things like, you can represent it as an adjacency matrix, and I can see connections between various parts. There's a whole slew of things you can do with this. Here, I don't know if I have the proper video for it. I'm not going to show the video just because I think the video, I didn't test it beforehand. So here's here's a no-link diagram for various places in Australia. It's a bundled flow, so the total flow, I think, of data between the various parts. But if you turn your adjacency matrix on its side and show Australia twice, you show how this connects with, so let me see here. I can see the connection between here, and I'm assuming I gotta see the other side. Oh, and here. It allows you to, by turning it on its side and showing two representations, you can see visually the connections between West Australia and I'm assuming Queensland. I don't know my Australian geography. If you're Australian, I apologize. Um, Tasmania, right? So Tasmania is not really connected to. Here's Tasmania here. Who are they connected to? So I can read off this West Australia. There's no real connection here. By adjusting it to its side, it allows me to be able to read off the connections between a geographic space. And so this is the input, this is the output. By turning it on its side, I can read off how this connects to other places. So West Australia is up here. Everything in West Australia, if I, so what would I do here? I would go down this side, and that would be where so West Australia, Queensland. I can read off this, and West Australia and Queensland, there's a fairly high transfer rate. And so Queensland and West Australia, it's going from West Australia to Queensland fairly regularly. For example, people have spent a large amount of time on this, more than me talking, which is surprising. I'm going to cut ahead of myself here. So there are two different websites I want to show you. There is Visual Complexities, VC website. It's just a list of all the graph visualizations or a bunch of graph visualizations that they found. And then we also have trees. We're going to talk about trees in a little bit, but I want to hit this as an in-class exercise. A tree is a graph, but there is a root. Everything goes down from that. So we have a parent and child. This is a parent. This is a child. So this comes for this, like the folders that you have on your C drive, right? On your computer, you have folders, a folder within a folder within a folder. And you need to know how far from, you want to be able to find out who your great-great-grandparent is on the tree. You want to see who your parent, siblings, uncles, aunts on the tree are. You want to see what other things you want to see if two things are related to one another, or this comes up when it comes to object-oriented programming, because you have inheritance, which forms a tree, for example. That's why computer scientists love this. You'll see it in 2400, whether you want to or not. So these are siblings, for example. They have the same parent, so they're called siblings. This is a node in the diagram. This is another node, just another item. And you can represent these trees using space fillers, like a tree map. This is a set of all technology companies. Here is Google within the technology companies. Here's Facebook. Here is, I don't even know. And then there's telecom companies. And inside telecom companies, there's a bunch of other companies. Here's financial sector. Here's money center banks, the set of money center banks. And that forms, what this is the size of this node represents presumably percentage of the amount of market that that company has for all the central banks. So this is how much all the money-centered banks are in terms of market capital or the amount of money they're making, let's say. Uh, this is how much this particular bank makes up from this total. What we have with a tree map, and they're very hard to read off, is I can fill in the spaces so that how much of the stock market is Google? It's this much, but it's within this particular, it's within internet information companies. And I can compare Google to Facebook. I can compare Google to Amazon over here. It says how big each of the companies are, but I also get who, how the hierarchy is. This is in here, which is in technology, which is then inside of the entire financial institution, or the entire inside the uh, not TSX, NASDAQ, I don't know, New York Stock Exchange. I don't know where Google's listed. And then we have another visualization of trees. What I'm asking you to do for the next little while, maybe 5 minutes, and then we'll pick it up again next time and look over what you submit. So I'll leave it open for you to work on afterwards. Find your favorite tree or graph on treeviz.net or Visual Complexity, so either of those links. Why do you like it? What's so great about it? Or maybe it's something you hate. If you want us to go with hate, I'm okay with that too. But find something. I was going to go with find your favorite visualization, what you thought was really cool. Why did you think it was really cool? Why did you think it was interesting? And then we're going to submit to the Google Drive. So I'm going to leave. We're got like a 4 minutes to look around this. You can play around with this, and when we pick it up again next day, we'll explore this again. But I want to give you some time in class right now to have a look at this, just to apply what we're looking at. Okay, I'm going to mute, but I'm still online waiting and to answer any of the questions. So go to treeviz.net or Visual Complexity and see what kind of graphs and trees have already been discovered and already been sort of identified. Okay, it is 9:55. I'm assuming maybe you have not had a lot of chance to look at all of these visualizations. There's a lot of them. We will pick this up again next time. I just don't want to take up too much of your time. You can keep on looking at them. I'm all for that. We're just going to look at them for a bit longer on Thursday, and then we're probably going to move on to, I'm thinking scientific visualizations, but I'm all for anything you want to look at in particular. So just let me know if there's something in particular, or if you have any questions about your project. I want to look at your sprints, how things are coming along. So far from the projects I've seen, they're looking fantastic. I'm very excited. All different technologies, but you guys are bringing your A game. I'm really, really impressed. So keep up the good work. I think you're going to have some things you can be really proud of at the end. All right. With that, I'm going to stop the videos and everything here. Just keep me informed, and we'll pick this up again on Thursday.